This video is to help you guys review for your quiz tomorrow. Remember, your quiz will cover exponents, rational exponents, simplifying radicals, and graphing exponential functions. So for example, we did a lot with exponents in our exponent rules. So for number 1, we have 3a cubed squared times 4a to the 5th. Alright, so with this squared out here, we have to distribute it. So that goes to everything inside our parentheses. And we also multiply our exponents. So 3 to the first becomes 3 squared. A cubed becomes a to the 6th. And then we bring down our 4a to the 5th. 3 squared is 9. And now we simplify. 9 times 4 is 36. A to the 6th times a to the 5th. We're multiplying straight across, so we add our exponents. And we get a to the 11th. So our final answer is 36, a to the 11th. Looking at number 2, we're dividing. Whenever we divide, we have to simplify our numbers, then subtract our exponents. So to start with, we have 4 over 6. That simplifies to 2/3. When we look at our exponents, we have x squared divided by x cubed. So we subtract. 2 minus 3 is -1. Then we have y to the 7th divided by y to the 4th. 7 minus 4 is 3. We don't want to have a negative exponent, so we move our x to the bottom. So we end up with 2y cubed over 3x. We also worked with rational exponents. Rational exponents are the ones where we have fractions. So we're looking at 125 to negative 2/3. We can write this as a radical for 1 over, right, because we don't want a negative exponent. So 1 over the cube root of 125 squared. The cube root of 125 is 5. So we have 1 over 5 squared, and 5 squared is 25, so our final answer is 1 over 25. Don't forget to move it to the denominator if you have a negative exponent. Looking at number 2, we have x cubed divided by 25 raised to 2/3. Okay, so we have to take this and distribute it to the top and the bottom. So we have x cubed to the 2/3 over 27 to the 2/3. Whenever we have our parentheses, we multiply. So 3 times 2/3 is just x squared. And we can rewrite 27 to the 2/3 with a radical, which would be the cube root of 27 squared. The cube root of 27 is 3. We have x squared over 3 squared, and 3 squared is 9. So our final answer is x squared over 9. And we also simplified radicals. Remember the number that's in our little v in this area right here, that's called our index. Alright, so that's what we're looking for when we're looking to pull out groups. So first we can start with our factor tree for 75, which can be 3 and 25, and 25 is 5 and 5. So we can rewrite our radical as 3 times 5. Oop, that was terrible. 3 times 5 times 5. And then we have a squared, which is a times a, and b cubed, which is b times b times b. Now we go to our index, and this is a 2 if nothing's there, so it's our square root. So we're looking for groups of 2. So we have 2 5s, 2 a's, and 2 b's. For every group, we pull one out. So we have 5 times a times b, then our square root, and under our radical, we're left with a 3 and a b. We can't simplify that anymore, so that's our final answer. 5ab times the square root of 3b. Look at number 2. We have a fourth root. So when we go to find our groups, we have to look for groups of 4. So we can start with our factor tree for 162, and that's 2 and 81. And 81 can go to 9 and 9, and 9 can go to 3 and 3, both 9s. So we can rewrite this as a fourth root of 2 times 3 times 3 times 3 times 3. We have 1x, and then we have y to the fourth, which becomes y times y times y times y. Now, because of our fourth root, we're looking for groups of 4. So we have 4 3's, and we have 4 y's. For every group, we pull 1 out. So we end up with 3 times y, and underneath our radical, we're left with a 2x. Again, we can't simplify that anymore, so our final answer is 3y times the fourth root of 2x. And lastly, we looked at graphing exponential functions. For this function, we have 4 times 1/2 raised to the x minus 1 plus 2. So if we think about our parent function, all right, our parent function is the ab to the x. So in this case, our parent is 4 times 1/2 to the x. So we can start by making a table of values. So 0 is usually an easy one because 0 makes our y-intercept, and our y-intercept is our a value, which in this case is 4. This is x and y. Then we can plug in 1, and 1/2 to the first power is just 1/2, and times 4 is 2. Alright, 1/2 squared is 1/4. 1/4 times 4 is 1. And you can even do some on the left side of our axis. So we can do -1. 1/2 to the negative first power is just 2. And 2 times 4 is 8. So now that you have a few values, we can plot these points. So we can go to -1, 8. We can go to 0, 4. Oops. We can go to 1, 2. And 2, 1. So this is what our parent function looks like. If you want, you might want to do a little dotted line. Our asymptote right now is at 0, our x-axis. And now we can come in and we can apply our transformation. So compared to our parent function, we will go right 1, because it's the opposite h value. So this would be a positive 1, and we're going to go up 2. So we're going to take each of our points and go right 1, up 2. So we'll start here, right 1, up 2, right 1, up 2, right 1, up 2, and right 1, up 2. Alright, our asymptote will go up 2. So it goes from y equals 0 to y equals 2. And we can connect our points to make our graph. And that's our graph of 4 times 1/2 raised to the x minus 1 plus 2. One more graph is -1/2 times 4 to the x plus 3. Alright, again we have a transformation here, so we can look at just our parent function. So if you want to look at our different transformations, we know we're going to be going up 3, and we know we're going to be reflecting because we have a negative a value. Alright, so if we look at just our parent function, we can look at -1/2 times 4 to the x. And if we plot some points, alright, we start with 0. If we plug in 0, we go to our a value, which is -1/2. We plug in 1, we end up with 4 times -1/2, or just -2. And if we plug in 2, we end up with 16 times -1/2, or -8. Alright, so if we go to plot our points, if I can find the marker, alright, 0, -1/2, 1, negative 2, 2, negative 8. All right, again, our asymptote's still at y equals 0. So if you wanted to do a dotted line just to see what the graph looks like. All right, now we can apply our transformations. And in this one, we're not going left or right. We're just going up 3. All right, change the pen color for you. Go green. All right, so we're going to take each of our points here, if I can find this marker, and we're going to go up 3. So we're going to go from 1/2 and we're going to go up 3. 1, negative 2, up 3. We're going to go 2, negative 8, up 3. All right, our asymptote's also going to go up 3. So we're going to go from y equals 0 to y equals 3. And then we're just going to connect our points. All right, and there's our graph. So if we think about this graph, if we look at our b value is 4. So even though this graph is reflected, it's still exponential growth. It's just exponential growth that has been reflected. If we think about our domain and range, our domain is negative infinity to infinity, because we cover all x values. And our range, in this case, we're going to be coming from the ground, we're coming from the bottom, negative infinity, and we're stopping at our asymptote, which is 3. And remember, we never have a value on our asymptote, so we use a parentheses because we are not including that value. If we go back to the previous graph, all right, our b value is 1/2, so that tells us it's decay. All right, if we think about our domain and range, our domain is always negative infinity to infinity, and our range in this case, we're starting with our asymptote and we're going to infinity. And our asymptote in this case is 2. So we're going from 2 to infinity, and again, we're not including our asymptote because we don't have a value there, so we put a parentheses. And that's all we've done so far with exponential functions.